Assalamualaikum warahmatullahi wabarakatuh, and good morning to all students. Okay, so as you see the screen here now, we are going to continue our discussion on topic 2 for semester 2 at this moment, in the topic of differential equation, and we'll look into the second part, the third part of it, which is application of differential equation. Okay, please refer to your tutorial book. In a part of tutorial questions, then there are only 4 questions of application. So I think that I decided I have to select 3 out of 4. So please double check with yours. Hopefully that all of you will get it all correct. Okay. The first question, a curve passed through the point of 0, 0 has a gradient of dy dx at a point of xy that satisfies the differential equation of this. Find the equation of the curve. Okay, so overall of these questions, meaning that let's say there's a curve, okay, that curve passing through the point of, this is what we call the coordinate of 0 and 0, has a gradient of dy dx, okay, the gradient which is dy dx at the point of xy that satisfies the differential equation, okay, meaning that if I can imagine this one here now, e power of negative x squared dy dx equal to x y plus 1 squared. Let's say if I recall explaining this, because from y equal to fx, and once we find the recall the dy dx, it gives us the gradient of the curve. So dy dx equal to x y plus 1 squared and divide by e power of negative x squared. So this is the dy dx. Okay, now find the equation of the curve, meaning that we are going to find out what is the equation of y equal to fx. You get it? Okay, now from the equation given, then e power of negative x squared dy dx equal to x times y plus 1 squared. So then, using separable variables, this one here now multiplied with 1 over e power of negative x squared, and also we're going to multiply with 1 over e power of negative x squared here, and also divide by y plus 1 squared on the right side. So we also going to divide by 1 over divide by y plus 1 square on left side. So it gives us 1 divided by y plus 1 square dy equal to, okay, x divided by e to the power of negative x square dx. Okay, so integral of this left and right. As you can see here now, on left side, recall this sign of equal sign here. On left side is all the variable of y, and on the other side is all the variable of x. Do you find any variable of x left here? No, right? And also there's all x on the right side. So integral of this, if I make this one as a y plus 1 to the power of negative 2 dy, and what about this one here now? 1 over e power of negative x squared. Power of negative means that 1 divided by 1 over e power of x squared. So simplify this, you're gonna come up, turn this upside down, they come up with e power of x squared divided by 1. Okay, so then simplify this. E power of x squared multiplied with x dx. Okay, now integral of this. Okay, you still remember then? Okay, so please refer to chapter 1, integration. So integral of this give you y, sorry, y plus 1 to the power of integral, the power index plus 1, so negative 2 plus 1 power of negative 1 divided by negative 1 multiplied with derivative of y respect to the y, 1 here. Okay. And then what about this one here now? On right side here, integral of e power of x squared x dx. So let's say if I come up with a substitution of u equal to x squared, so then du equal to 2x dx. Okay, so now what we have here is x dx, and we cannot simply substitute this one, this equal, we call it term here 2x dx, because it's not equal to this one here, unless if you substitute this one into the equation, then you multiply with 1 over 2. Okay, so for this case I prefer to change this into a du over 2 x dx. Okay, x dx and x dx, am I right? So then integral of e to the power of u equal to x squared e power of u and x dx equal to du over 2. Over 2, it is 1 over 2. So take it outside. So then this one here now, negative y plus 1 power of negative means that it is 1 over y plus 1. And negative here equal to 1 over 2 integral of e power of u equal to eu plus c. And don't forget to change this back into the term of x, 1 over 2 e x squared plus c. And this one here now, it is negative 1 over y plus 1. We want it in the form of y equal to fx. So then, make this one as y plus 1 our negative here. Okay, so everything of this reciprocal of this one here, 1 over 2 e power of x squared plus c. Okay, I bring it to the side here and multiply with negative left and right. So y plus 1 equal to negative 1 divided by 1 over 2 e power of x squared plus c. Then y equal to negative, for this positive, bring on the side become negative. So then okay, negative 1 minus 1 over 2 e to the power of x squared plus c. Okay, so just thinking of how are we going to simplify this, especially for this one here. Okay, let's try with 1 over 2 e power of x squared plus c. And simplify this as a this is e power of x squared divided by 2, so this is over 1. To make it 2 here, then come up with 2. Okay, so then e x squared plus 2c divided by 2. So 1 over this come up with negative 1 minus 2 divided by e to the power of x squared plus 2c. Okay, never mind. It might be different from the answers given to recall the provide at the end of this topic, but it's okay because it's how you simplify that. It might be a little bit different with sign of positive and negative and in this form, but which I think that this is more than enough. Okay, so that's the solution for question number 11, the first question I chose. Then next, suppose that electricity is draining from the capacitor at a rate of proportional to the voltage. It's mentioned here now. Okay, with the if t is measured in second, this is a question here now. dV dt equal to negative 1 over 40 V. Okay, so what draining? Give us, recall the situation has come up with negative here. Solve the equation of V by using V naught, denote of the value of V when t equal to 0. Okay, but before that, let's solve this part, first part here now. So let's bring this V to the other side. 1 over V dV equal to negative 1 over 40 dt. Okay, so they are all V on the left side and a constant with a dt on the right side, the other side here. So we are going to separate the variables, integral left and right. Okay, I might also recall, write down the symbol of integral curve here or just here. Because this is a constant, it will affect nothing or we call to integral. So just imagine that if this means dt, which is 1, integral of 1 respect to the t. Okay, integral of 1 over v, so natural log of v equal to negative 1 over 40 t plus c. And come up with the constant of Euler constant of E here and also E here. So V equal to E to the power of negative 1 over 40 T plus C. Please refresh our lesson in recall semester 1, chapter 1, index for A to the power of n plus n equal to A to the power of n times A to the power of n. Still remember that? Okay, so then let's imply this here, which is e power of negative 1 over 40 t multiplied with e to the power of c, and simplify this as an a e power of negative 1 over 40 t. So let's note something here with a equal to e to the power of c. Okay, then this is the equation of this voltage according to the question here now. So then solve the equation of V by using V naught. V naught means that the earliest or initial voltage when t equal to 0 means that the beginning of the experiment. So then when t equal to 0, V equal to V naught. Okay, so it means that this V will replace with V naught here, the initial V naught equal to A e power of negative 1 over 40 negative 1 over 40 t and t equal to 0. Okay, so negative 1 over 40 times 0. 0, okay, everything equal to 0 and e power of 0 equal to 1. Then V naught equal to an A. Substitute A here with the symbol of V naught, the initial voltage. V equal to V naught e power of negative 1 over 40 t. And then the next question here, how long will it take for the voltage to drop to 10% of its original value? Meaning, this is the initial, the earliest voltage at the beginning of the experiment. Vt equal to 0, V0 here. And this is the current, the latest after the experiment from time to time. So, we'd like to find out what is the value of t. Okay, when the voltage drop to 10%. So, it is something like this. It is 10% of V0 equal to V0 e power of negative 1 over 40 t. Okay, divide by V0 left and right. So then 10%, I note as a 0.1 or 1 over 10%. 10%, 10 over 100 or 1 over 10. Okay, you may write down either one here. Okay, so 0.1 equal to e power of negative 1 over 40 t. So to eliminate this sign of constant of e, then come up with a natural log of 0.1 left and natural log of e power of negative 1 over 40t. Then it is negative 1 over 40t. And natural log of 0.1 log 0.1 equal to negative 2.301. Okay, so we like to find out what is the value of t here, multiplied with negative 40. So then 40 divided by 40, negative times negative become positive. So then multiply with negative 40 on the other side too. So then t equal to multiplied with negative 40 equal to 92.1 second. Get it? Okay, so try to understand the situation here, the question, and follow the question, the flow one by one. The next question actually that the last final question for this video for today. The rate of growth of bacteria is proportional to the amount present. Let n be the number of bacteria present after t minutes when the differential equation is given by this one here now. So the value is positive because the growth of bacteria means that the population or numbers of bacteria is getting bigger and bigger. So dn dt equal to k, and is given in the question there. So on left side of we call equal sign here, this is house of n and this is house of t. K is just a constant, just like the numbers of 5, 6, 7, 10 or whatever. Okay. So then separate the variables is 1 over n dn equal to k dt. So we successfully separate the variables of n with t here. So integrate left and right. So again, natural log of n equal to k t plus c. So come up with a constant of e here and here. So then n equal to e power of k t plus c. It is e power of kt multiplied with e to the power of c. It is a e power of kt. Okay. And now Initially means that the beginning of the experiment. The beginning of the experiment, we put this one as a t equal to 0. T not equal to 0. It's not the time equal to 0, but then this means that it's the beginning of the experiment. If we begin it at 12 noon, then we consider that 12 noon is the T0. If we begin experiment at 2:30 p.m., so we consider that is the beginning, so T equal to 0. So then, when T not equal to 0 and the N not equal to 10 bacteria, okay, and which is N equal to N naught. The initial numbers of bacteria is 10, T equal to 0 here, so then N equal to N naught, okay, and substitute with N naught here, N naught equal to A e power of K and T equal to 0. K times 0 equal to 0, e power of 0 equal to 1. 1 times A equal to N naught. So then, this A, we replace with N naught here, so N equal to N naught e power of KT. And 1 minute later, when T equal to 1, then the current numbers of bacteria, there are 15. The initial is 10. The beginning of the experiment, the N is 10. After 1 minute, the numbers increase from 10 to 15, means that there are additional 5. So, the current numbers of bacteria, which is 15 equal to N naught e power of K and T equal to 1. Okay, N naught equal to 10 here. Okay, for this N naught, which is equal to 10. Okay, then e power of K and T equal to 1. So then 15 divided by 10, 3 over 2. Then e power of K. So eliminate this constant of e. So we come up with natural log of 3 over 2 equal to natural log of e, K here. So then K equal to natural log of 3 over 2. Okay, you may use the calculator. So then the answer is K equal to the constant of this, which is 0.45. 0.405. Okay, so now A equal to N naught, where N naught equal to 10. Okay, so N equal to 10 e power of K, which is 0.405 NT. Okay, class. So we shall think that K equal to, actually that we can leave it in this answer here, natural log of 3 over 2, because we want we call the result of N, that we call the equation of N in this form as given in the question here. So then N equal to 10 e power of T, okay, natural log of 3 over 2 multiplied with T. T ln 3 over 2 or ln 3 over 2 times T is just the same. Okay, there you go. Question A. How long bacteria will present after half an hour? So according to the beginning of the question, initially T0 and 1 minute. So meaning we're talking about the time in a minute from 1 minute later. So half an hour, so the number of current n after t equal to 30. So n for this one here, n equal to 10e power of natural log of 3 over 2 and t equal to 30. Okay, you may use your calculator here for this one here. 10 okay, e cannot. Okay class, so the numbers of n for this after half an hour, so that I have try using the calculator as you see on the screen here now, and it is 1191751 0.5, make it 1 here. Okay, so how long will it take the numbers of material to reach 1000, meaning n equal to 1000. The point the question is how long will it take, or means that the numbers of t for time. Now n equal to 1000, then e to the power of natural log of 3 over 2 t. Okay. Okay, so 1000 divided by 10, which is 100, then e power of natural log of 3 over 2 times t. Okay, for this one you may also use a calculator or simplify everything here. So the answers be given there for this one here is t. Okay, you try by yourself until you get answers of t equal to 11.4 minutes. Okay, so there are 3 questions of application of differential equation. Hopefully that this our discussion for this time helps you to continue with the rest of the question of application in the collection of PSPM or past year questions. So that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.